Hello, welcome to this video where we have two examples where we have to find the area between curves. In this first example, we have two curves, y equals e to the x over 2 and y equals e to the negative x over 2. These come straight from my quizzes, and I wanted to be able to give a good example of what a quiz question would look like where there's no graph given here. And there's one more line, we have one more part to the region we have to figure out, and that's x equals 2 log 2. Log 2 is a constant. Double that, you get a constant. X equals a constant is a vertical line. All right, so what does e to the x over 2 looks like? It looks like e to the x. It crosses the y-axis at 1, and it grows exponentially. What about e to the negative x over 2? We take that same graph, reflect it about the y-axis, and we'll have exponential decay instead of exponential growth. Okay, we're in the first quadrant, so we don't care about what's going on in the second quadrant. And so exponential growth, exponential decay, and a vertical line. Looks just like that. Our job? Find the area between those curves. Find the area of that region. Our upper curve is the e to the positive x over 2. Our lower curve is the e to the negative x over 2. We're going to integrate from where to where? Well, we're going to start at x equals 0. They both cross at 1 on the y-axis. So we'll start at x equals 0, and then we'll be done by the time we get to x equals 2 log 2. That's it. That's the setup. So how do you integrate e to the x over 2? Well, how do you integrate e to the kx? What function has e to the kx as its derivative? You would think it'd be like e to the kx. But then the chain rule will come in and bring a k to that. There's no k out front here. There's no constant in front here. That must have canceled, and it cancels because the way you take the antiderivative of e to the kx is you take 1 over k times e to the kx. That way, when the k comes down, it cancels. So the antiderivative of e to the half x would be 1 over a half e to the half, or twice e to the x over 2. And so the other one's going to be twice e to the negative x over 2. Okay? You can do it by U-sub, but it's not necessary. Hopefully, you could do it with just intuition. And we have our antiderivative. Fundamental thermocalculus says plug a 2 log 2 into that. Get a result. And subtract from that what you get by plugging 0 into that. All right, let's do it. If you plug in 2 log 2, the very first thing x that happens to x is it gets divided by 2. So those 2's cancel. And you just have log 2. Well, what is e to the log 2? That cancels. It's just 2. Be careful with the other one, though. E to the negative log 2, you don't get that cancellation. That's not negative 2. You have to take that negative and use the log property and put that up on the exponent on 2, and then you can cancel. Okay, now it's e to the 2, e to the log of 2 to the negative 1. Now you can cancel. It's really a half. Okay, so 2 times 2 plus 2 times a half. On the other side, e to the 0 for both of them, that's going to be 1, and it's plus. So now, where did the plus come from? Why is there a plus there? Well, the antiderivative of e to the negative x over 2 would be negative 2 e to the negative x over 2. To be able to cancel the chain rule, that's going to be the negative 1/2 that comes down. And so the double negative makes that a plus. Very sneaky. Be careful about that. Okay, so then we're done. We have 4 plus 1 minus 4. Oh my gosh, the answer is 1. That area right there is exactly 1 unit squared. 1 square unit. The same as a 1 by 1 square. All right, great. Thanks for watching. My name is Nakia. Please like and subscribe, comment down below. I'll see you in the next video.